right, hey, Emma and who else is missing? Emma and Luke. Sorry, Luke. Emma and Luke, 6-4. Fundamental theorem of calculus. You guys know the fundamental theorem of calculus. I just didn't call it that. Are you listening? Do you have your notes?
Yeah.
Okay. Fundamental theorem of calculus. You already know this. Here's what the fundamental theorem of calculus says. Here is my integral, right? Okay. F of x is the equation that you have. Dx is the variable that you're taking the derivative to. And then a and b tell you where you're finding the area from. So whatever your curve looks like, here's where a is, here's where b is, and like your curve does one of these, you're finding this area from a to b. You're finding that area, right? Okay. The thing that you do to find that area is you take the antiderivative, which they denote as a capital letter. You plug in b. You subtract what you get when you plug in A, right? You plug the top number in, you subtract what you get when you plug the bottom number in. Like, we know that already. We did that, like, in 6-3, because I jumped the gun and I taught it to you already, okay? All right, so f of b minus f of a, that's what you do, okay? So here, let's do example 1. So, we're doing the area, just so that you're aware of what we're doing. Do you know what x cubed looks like?
Yeah.
He looks like this and he looks like this, right? What? We'll write the formula. Yep. So we're doing this area from 1 to 3, right? So like 3 is over here. We're trying to find the area underneath of this curve right here, bound to the x-axis from 1 to 3. Oh, why? I don't know why I put 1 at 0. Somebody know why I put 1 at 0? I don't know. Let's fix it. 1 is here, 3 is here. Bleh. There we go. So this is the area that I'm trying to find from 1 to 3. That's like in a sense what we are trying to locate, right? Okay, I'm trying to find that area, all right? And I do that by finding an antiderivative. The antiderivative is 1 over n plus 1, x to the n plus 1, okay? So I'm going to deal with this part first, x to the 3rd power, okay? So your n is the exponent, so this will be 1/4 x to the 4th power, got it? All right, then the notation that I use is I always put a little bar afterward. This is the notation they use. It looks like this. Theirs looks like a little bracket, okay? But I just put a little bar here, and I put my numbers here, 1 and 3. And this step right here says, I have found the antiderivative, but I have not yet plugged my numbers in. That's how you can keep track of where you're at, okay?
Which one do you do first? Like, how do you know what you're going to do first?
You plug in the top number first, the b value first,
Oh,
the rightmost number first, yep. So we're going to plug in 3 first, so 1/4 times 3 to the 4th power, whatever that is. And I'm going to subtract when I get when I plug in 1. To the 4. Oh, I don't know why I put 3. Okay, this should be a 4. 1/4 times 1. Okay, 3 to the 4th power. Do you know how you do 4th powers? 4 3s. These 2 3s make 9. These 2 3s make 3s make 9.
Oh,
9 times 9 is 81, right? 81. Okay, 1/4 of, I'm just going to do this. I'm just going to call this 81 over 4. Let's just do that. Okay, 81 over 4. I'm going to do that real quick. Minus 1 to the 4th power is 1. And 1 times the 4th is 1/4. What is 81 over 4 minus 1 over 4?
80 over 4.
80 over 4, which is?
20.
20. So this area underneath of this curve is 20. What?
80 over 4 is 20. It's always
Yeah, but if you do it in like number ways, it would be 81 minus 0.25, and that is not 20.
No, 81 over 4 minus a 4th.
81.
81 and a 4th is 20.25.
Oh, I didn't think 81 times
minus 0.25, right? Okay, so that comes out as an area of 20. So the area underneath of that curve right here has 20 units. Woo, that's what we just found. Got it?
Cool.
All right, this one. Let's do this one. This one is a little bit harder of an antiderivative. So we've got this one on here. To rewrite him, I'm going to go up top here. This is 3x to the
1/3.
1/2 power.
Oh, yeah.
That's not a cubic root. That's 3 and the square root of x, right? 3x to the 1/2 power. All right, now the deal here is, if you need to write the equation again, 1 over n plus 1, x to the n plus 1. Whoop. Okay, n plus 1. So I have 1 over 1/2 plus 1. And instead of it being x, it's actually 3x.
Why don't they put a variable?
And then to the 1/2 plus 1 power, right?
You know, I don't think we ever use u as a variable.
Oh, you just wait till we do 6-5, the next section, when we do substitution.
Okay.
We'll talk about u and du.
There's another one that I thought.
You-
Ah, u and du.
Oh,
No.
Okay, all right, keep going. What is 1/2 plus 1? What does this come out to be?
1.1.
1.5, which is 3 over 2. I'm gonna call it 3 over 2. Okay, what's 1 divided by 3 over 2?
1.1.
You flip it to the top.
Wait,
What?
we got 2/3.
1/2 plus 1 is 3 over 2, is 1.5. Okay, if you flip them to the top, you would be 2/3, right?
I knew it.
Okay, oh shoot, but I have to take that times 3 now. So 2/3 times 3, what's 2/3 of 3?
2.
2, right? 2/3 of 3. This would be 2x to the
We got power.
What are you doing?
3 over 2 power. Got it? 2x to the 3 over 2 power. That is my antiderivative. I'm going to plug in 1 and I'm going to plug in 4. Got it? Got it?
No.
In theory.
Okay, in theory, 2 times 4 to the 3 over 2 power minus 2 times 1 to the 3 over 2
I don't
power.
like 3 over 2 power. That's kind of.
Okay, alright, the 3 over 2 power means the square root of that number cubed. Right? Right? What's the square root of 4? 2 cubed is
8.
8, so this number is 8. And 2 times 8 is 16. Minus 1 to the 3/2 power. I don't even care what that is because 1 to any power is just 1. And 2 times 1 is 2. So final answer is 14.
Great number.
Got it? Happy with that? That was example 2.
We're
We
done.
have an example 3?
Yeah.
Example 3.
No, we don't
Ugh.
have to.
Value.
Just keep the absolute in there. It's fine.
Ugh.
All good. No more. All done.
Wait, doesn't that mean we
I don't
can't
want to do
it
this.
because there's no
We
value?
have to, let me see your homework assignment. I don't know if I want to do an absolute value one. So let me see if you have one in here.
Oh, I thought you wanted to. We don't have. They're all parentheses.
Okay, they're all regular. Okay, but we're gonna do this one, but we're gonna pretend it's not absolute value, just to get practice in, okay?
Just
So,
2x minus 1.
Just 2x minus 1 is what we're doing, okay? So pretend that those are not absolute values, because I'm not gonna make you find the antiderivative of an absolute value.
1/2
Okay.
2x squared.
Alright, so we're going from 0 to
Minus
2 of 2x minus 1, right? So just to be clear, 2x minus 1 is a linear function. It starts at -1 and it goes up 2 over 1, right? Up 2 over 1, up 2 over 1. So we're doing this, right? And we're going from 0 to 2. Got it? So he will have some negative area here mixed with positive area here, and we're trying to figure out what those are. Does that make sense? Okay, that's what we're trying to find, alright? Whatever that area is. Alright, we need to find the antiderivative of 2x minus 1.
It's
2x
2.
So,
squared.
This is x to the first power. This is 1/2 1/2 times 2x. Oh, and the x is squared. 1/2 times 2x squared. Got it? That's the antiderivative. Minus, what's the antiderivative of 1? 1x, okay? So this is really just x squared minus x is what he is. Make sense? Okay? Now, we have not yet plugged our numbers in, but we have taken the antiderivative, so I'm going to do 2 and 0.
Oh, I see what you're
Okay?
saying. 0 minus 0 is 0.
And the last thing I'm going to do is I'm going to plug in 2. So 2 squared minus 2 is what that is, if you plug 2 in. Okay, minus, I love it when 0 is the bottom number, because guess what?
0.
This will always end up being 0 on the right side.
What's the absolute value do with it? Just like when you get done, it just has to be positive?
I'll show you, hold on. 2 squared minus 2, this is 4 minus 2, which is 2, minus 0. This guy has an area of 2. Now, Jake, Jake?
So confusing.
the absolute value
Oh, it just means it has to be pivoted.
actually looks like this. So instead of going down over here, he goes up that direction. So this area that we said was negative down here is actually a positive area right there. So,
if that was like -2 to 0, it would be positive.
no.
Why?
So here is what you would actually end up doing. Are you ready for this?
No.
Confusion. Are you ready for this?
We don't want to.
Okay. Alright, if this confuses you, don't listen, but if not, listen to this. Ready? Okay, here you go.
Okay.
When you're doing an absolute value, this spot right here, do you know where he touches right here? Like, where is this coordinate point where he touches? 1/2, right? So, what's happening is for an absolute value, this chunk right here is represented by 2x minus 1, true? Like, this is the equation 2x minus 1. But that is only going from 1/2 to 2, right? 2x minus 1, right? There's that. I'm going 1/2, because 2x minus 1, he's gonna touch right here, this coordinate right here at 1/2, got it? Okay, but this little half of him is
negative.
actually represented by negative 2x minus 1,
So smart.
right? So we're gonna evaluate this from 0 to 1/2 and add it to what we get when we evaluate this, right? Does that make sense? Like on this half of him, he's going negative, he's going downhill, and the other half he's going uphill. So I do negative 2x minus 1 and positive 2x minus 1, and I just do the 2 different chunks.
I don't like
Make sense?
So
So you
That's
have
what he
to
will
do
look like.
like 2 scenarios or 2
Yeah, you would
cases?
have to do 2 different things, 2
Okay.
different antiderivatives, plug those numbers in, and then add your final answer together.
It's so
Yucky.
gross.
Yucky, okay? So that's why we pretended that the absolute values weren't there. That's gonna take
You
some more
stop.
practice.
I know
Okay.
it's you the whole time.
Okay?
This is Sarah.
All right,
Sarah doesn't ever
next
have to
thing.
voice.
I think I've already addressed this at one
That was
point,
kinda cool.
and this is kind of cool that this happens. But technically, when we take the antiderivative, it was Kyle that said it the other day. Technically, when we take the antiderivative, it has a plus c on the end of it, right? Okay. So like your antiderivative is something plus c and something plus c. But the deal is that when we go to plug our b and our a in, when I plug b in here, I have a plus c, and I subtract what I get when I plug a in with the plus c. But plus c minus another plus c, these will end up canceling each other off. So that is why when we're plugging numbers in, we don't have to do our plus c on it, right? Okay, now, do you remember the difference between having numbers and not having numbers?
No.
Like if they have f of x dx with no numbers out here and what the a and b numbers do? These guys are called limits of integration.
Oh, gross.
Limits of integration. So it's just like you're gonna have your numbers that you're plugging in. Those are called limits of integration, okay? One of these is a definite integral, the other one is an indefinite integral. Which one is which?
The bottom one's
Definite
indefinite,
is
top
the
one's
top.
definite.
This one is indefinite,
Oh, I thought we were talking about numbers.
okay? This integral is an indefinite integral. I don't have numbers to plug in. So this is going to have a plus c. Will have plus c on the end of it, right? When I evaluate, when I find the antiderivative, that will have a plus c. Versus this one is a definite integral. Definite integral. And his answer will be just a number. I will get an actual number for the area. Make sense? Definite integrals are what you're using when you're finding an actual finite like area, versus indefinite is just finding the general antiderivative. Got it? Okay? So if you don't have limits of integration, it's indefinite. If you do, you're going to get a number for an answer and it's a definite integral. Happy with that? Make sense? Okay? All right, let's do this. Let's just go and have you do the top 6 and
None.
yeah, you can do one. You can do the first page, 1 through 9.
I don't know how to do graphs.
Let's do the graph ones.
Okay.
Let's do one of them together.
8.
Actually, 8 is going to be maybe the hardest one. I don't know. Let's do 8 together, okay? Now, all of these other ones you know how to do, maybe, probably. They are already written out as an integral for you, okay? But this guy, he is not written out in integral form. Can you write him out in integral form?
Yeah.
Okay, what's he going from? From what to what?
Two.
He's going from 1 to 2 on the x-axis, 1 to 2.
But
My
he
function
doesn't
is
go all the way. Oh wait.
1 over x, right? He's going to the x-axis, right? That's where we go from. Okay.
I can't see this.
And then we got dx.
What does
So if I write out the
dx mean?
integral,
What does that even mean?
dx just means that's my variable
Are
that I'm
they all
using.
shaded
I don't know.
Why do you
below?
have to put that?
I don't know. It's just a notational thing. That also helps you keep track of like, that's the original. I haven't taken the antiderivative yet.
Oh wait, that's the answer.
Okay, that's what you do. No. Now we gotta evaluate it. So it says find the area of the given region. So we have to find the area now, which means find the antiderivative, plug your numbers in. Okay. Now this guy, I don't like the way he's written. I can't take the antiderivative of that yet.
X
He
to the
is
top.
x to the
Negative.
-2 power. That's what he is. Okay. So when I do my 1 over n plus 1, what is n? -2 plus 1. X to the -2 plus 1. Right? Okay, now, actually, -2 plus 1 is what? This is -1. So what's 1 divided by -1? This is -1 x to the
I got 0.
-1 power, right? -1 x to the -1 power. All right, let's fix him.
Right.
Okay?
Bottom.
If I put the x back down to the bottom, this is negative 1
over x
That's
to the
zero.
one.
over x to the first power.
Yeah.
Or negative 1 over x. That's what he looks like. This is his antiderivative. This is the antiderivative. Okay, but I'm going to put my little bar,
And plug in.
and now we got to plug in 2 and 1. Okay? So do you see how that works? Negative 1 over x. That was our
Negative
antiderivative.
And
Got it?
negative 1.
Alright, so plugging in first, we're going to plug in the 2. So negative 1 over 2. That's my first thing that I'm going to plug in. Minus what I get when I plug 1 in. So negative 1 over 1. Right? Okay?
That's too many
This guy,
negatives.
no. This is negative 1/2. 2 negatives make a positive. What's 1 over 1?
1.
What's negative 1/2 plus 1?
1/2.
It's just 1/2. So he will have an area of 1/2. Does he look like maybe he has an area of 1/2? Like an area of 1 would be this whole thing right here, right? That would be like that block.
How did you
So
get?
that's half of an
How
area.
did you get this?
What?
How did you get the first? Like,
This
1
first
over
bar
x
right here?
squared?
Oh my gosh.
Okay, 1 over x squared is the function. Is the
Oh,
equation of the curve. Yeah. Yeah. And then it's going from 1 to 2. That's it. Okay? Happy with
Are
that?
those shaded below?
What?
It's-
No, they're only ever shaded until you get to the x-axis. Because if you would shade below,
I mean those. Like, where are those shaded?
these are shaded from negative 1 to 3 until you get to here. They can't give you anything shaded below because that
No,
area
I
would
mean
never end.
The line. Below the line.
Yes, it's below the line. Yep, and this line is this equation.
Actually, it switches sides.
Hey, what?
Switches sides.
Okay,
I asked
so
you about this.
What do you mean?
It switches sides.
so
Let me draw.
0 to 1.
It switches what? What are you talking about?
So you got this shaded, right?
Yeah.
But then this comes down, that goes on, but then you shade this.
Correct, it would be. So if I were to have be solving from like here all the way up, so this is going from negative 1 to 3. If I would be going out to like, let's say 5, right? I would have to incorporate that negative area in there.
Mm-hmm.
But the only thing that they have shaded is from negative 1 to 3 on here. But yes, you're true. Yes,
Totally
that's
true.
exactly what it would be.
Can you do
Okay.
7 either by yourself or with us?
7, sure. Let's look at it. Okay, let's write out what the integral looks like first.
Half x squared
Okay.
minus a third x.
So what are you going from? From what to what?
0 to 1.
What?
0 to 1. Okay, x minus x squared. That's his function dx. Okay, that's the integral. Like that's what he looks like when I write him out as an integral.
And half x
Now I
squared
have to take the antiderivative. Okay, what's the antiderivative of x?
half x
1 over n plus 1, which would be 2, x to the second power, minus
No.
a third x a third.
1/3 x to the
30 seconds left
third.
and I got
That's
Got it?
gross.
Yep.
So there's that.
my
Now I have to plug in my 0 and my 1. Now 0 and 1 are really nice numbers to plug into this. Actually,
Oh, why did I
1
do
half times 1 squared minus 1/3 times 1 cubed. There's that one. Minus what I get when I plug in 0. Do you know what's going to happen when you plug in 0?
0 to 0.
Yep, it's going to be 0, right? I'm going to write it out, but it's going to be 0. So this guy goes to 0, like there's nothing left, okay?
That's 0.1.
1 squared is 1 times 1/2. So this is really 1/2 minus 1/3.
I don't know what that is.
Okay, change it to a denominator of 6.
It's a 6.
So this is 3 over 6 minus
2 over 6.
2 over 6, which is 1 over 6. That's his area. Okay, good?
Yep.
Does it look like that might have an area of 1/6? Like he touches up here at a 4.
I
He
don't
doesn't-
know
like,
how
he
you
doesn't go
tell
very high.
Any of that.
Like I know that area is not 10 because he only goes up to a 4th, right? So like you can guesstimate, like that seems reasonable, right?
Yeah.
Okay, all right.
Negative
Good to
1
go?
over 3.
That is what they're asking for. So do 1 through 9.
Oh my, I have to find all of those.
Here you go. Jake, this is for you.
No.
Number 2, dv instead of dx because that's your variable's name. It's not a u, it's a
What?
v. That's a
That's a U. You
v.
never number, it's just, and you take the antiderivative, it's just x, right?
Here's dt.
Isn't it?
Oh wait, 1 over 3.
So anyway, there you go. Okay, you're taking the antiderivative, you're plugging the numbers in.
X to the
Taking antiderivative, plugging the numbers
negative
in.
x to
Okay.
the third.
Be very careful on taking your antiderivative, otherwise everything else is screwed up.
When you, plug in just, or when you take the antiderivative of just a number,
Yes,
just-
it's that number x.
okay.
Yep. Alright, I'm gonna stop the video. Goodbye.
If it's just 3, the